If you haven't done so yet, please pause the video and attempt to solve the question on your own before listening on. For part A, in order to calculate the resulting charge on each capacitor, we can consider the following equation. We know that the charge is equal to the capacitance multiplied by the potential difference between the two plates of the capacitor. So all we're going to need to do is to plug in the capacitance as well as the potential difference given by the battery for both the 25 and 40 microfarad capacitor. So we've gone ahead and plugged in the known values, and when you compute that, you should get 1,250 microcoulombs for the first capacitor and 2,000 microcoulombs for the second capacitor. If you were asked to compute that in terms of millicoulombs, we just have to recall that 1 millicoulomb is 1,000 microcoulombs. So if you perform that conversion, then you would get approximately 1.25 millicoulombs. And then for the other capacitor, if we set up the same conversion, you would get approximately 2.0 millicoulombs. So those would be the correct answers to parts A. Now for part B, what we have to note is that the negative plate of one capacitor is connected to the positive plate of the other capacitor. And in that situation, the net charge on the two capacitors is going to be the difference in charge on each capacitor. Notice that if positive plate were connected to positive plate, then we would have summed the two charges. That would also be true if we connected negative to negative. But whenever we connect the plates according to their opposite polarities, then we have to subtract the two charges. So we'll go ahead and fill in the charge on the 40 microfarad capacitor as well as that on the 25 microfarad capacitor. So here we've gone ahead and plugged in the values that we computed earlier. We're leaving them in terms of microcoulombs in this case. And when we subtract them, we get the following for the net charge on the capacitors. Now in part B, because these capacitors are connected in parallel with one another, then we know that their potential differences are going to be the same. In other words, the potential difference across the 25 microfarad capacitor is going to equal the potential difference across the 40 microfarad capacitor. Remember from earlier, we said that charge is equal to capacitance times the potential difference. If we divided both sides of this equation by C, then we would have the charge over capacitance is equal to the potential difference. So what we're going to do is take each expression here for the potential difference and substitute it with the charge divided by the capacitance. Now at this point, just remember that we don't actually know the charge on the 25 microfarad capacitor or on the 40 microfarad capacitor, but their capacitances still remain the same. So we can actually fill in 25 microfarads here and 40 microfarads here. Now what we'll do is we'll solve for Q25 by multiplying both sides by the 25 microfarads. On the left side, of course, the 25 will cancel out. Now the microfarad units will cancel, and if you pick up your calculator and divide 25 by 40, you should get 5/8. So we can rewrite the equation as follows. Now, what we have to understand is that in the new combination of capacitors, the total charge is going to be the new charge on the 25 microfarad capacitor plus the new charge on the 40 microfarad capacitor. Now, we already figured out the total charge, and we have a relationship between the charges on the two capacitors. So what we can do is substitute in 750 microcoulombs here, and then since Q25 is equal to this expression, we can substitute that expression in for Q25. We can add these two like terms together, and then if we multiply both sides of the equation by 8/13, we're going to be able to solve for Q40. And when we do that, we get a value of approximately 462 microcoulombs for the charge, the new charge on the 40 microfarad capacitor. And now that we have that charge, we can take it and plug it into this equation, and that's going to allow us to find the charge on the 25 microfarad capacitor. And when we compute that, we get a value of approximately 288 microcoulombs. So that's the new charge on the 25 microfarad capacitor. And finally, to calculate the potential difference across the 40 microfarad capacitor, we just have to recall one more time that because these capacitors are connected in parallel with one another, that means that the potential difference on each one is the same. Now, we know that for parallel capacitors, the equivalent capacitance is simply the sum of the individual capacitances. We also know that the overall potential difference for parallel capacitors would equal the total charge on the capacitors divided by the equivalent capacitance. Now again, we already know the total charge is 750, And then we can substitute this expression in for the equivalent capacitance. And we already have the values of each capacitance, so we'll fill them in. And when we compute this, we get a value of 11.5 volts. Notice that this value is the potential difference across both the 40 microfarad capacitor as well as the 25 microfarad capacitor because they are connected in parallel. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and also subscribe to the channel so you can stay tuned for additional videos. And remember that you're welcome to send your own question into this email address, and I'll do my best to post an answer to it on YouTube.